It's still Saturday, the 30th September 2017, but this time it's block height 487,734. And we return, this time having problem solved and troubleshooted and science the F out of that problem we got just now. So, Shinobi, talk us through it. White space. What's the problem with white space?
All right, so the issue is with all the random messages you guys were sending us, different clients on different machines were interpreting white space incorrectly in different ways, and it was leading to a different computation of the message. The signatures weren't checking out. I could have sworn, our assistant got a new machine. I watched him take it out of the plastic in front of my eyes. I don't know what happened, guys, but what we're going to do now is we're going to sign the Merkle root hash that Chris did. Everything is checked out for all of us, and we're going to provide you the signatures and the addresses. It should verify no problems this time. And I guess the lesson is don't trust assistants.
No, the lesson is, look, usability is terrible in crypto. And even if you've been using it for years, like we all have, there's still something that's going to creep up on you and is going to surprise you. So yeah, all right, we tried to be cool and tried to get messages from the public chat box, and yeah, but this time we're just going to use the Merkle root, because the Merkle root of the block height that we were at when we started the last show will verify correctly on all computers. You won't have to escape out the spaces and so forth, because it's just, there are no spaces in it. So it's just easier this way if we just do a block of text, but otherwise we would have had to have escaped out the text. So, okay. Shall I show the peoples? So the link to the gist, the public gist, is in the description below, and I can take you guys through it. And so this is the message here. So when you go into Electrum, start a fresh instance, you can be in any wallet you like just to do the verification. What we're going to do is we're going to verify the messages that we got. So this is the message here. That's the Merkle root. And that acts as a timestamp in itself. It means that this video couldn't have existed any time prior to the creation of that Merkle root. So let's do ACNIX first. So he's the first cosigner, and that's the address. And then this is signature. So we click verify. It says signature verified. Okay. And then we go to Shinobi's, and we don't have to change the message because they're all the same. And we change the address. We change the signature, we hit verify. And what it's doing, for those who are new to Bitcoin, is taking this public key and it's figuring out the hash from this message here. And you can't get to this, as you saw, it needs to be exactly right. Everything has to be exactly right. If one character is wrong, the whole thing will not work. Verify, and that's my one there, which verified already in the previous one. Okay, and again, just a reminder that you can recreate our public key here with the information, the one starting 3NG9 and ends in YJV. Okay, and you can do that by taking the raw public keys, going to a website like Coinbin, or actually you can use any good client software, take the public keys of each of us, and very important that you do this in order, because we're co-signers 1, 2, and 3 respectively, and the order does matter to the address that you will end up with at the end. And then just paste it in, click submit, and then it will give you the same public key beginning 3NG9 and ending in YJV. And so that's really just a way of demonstrating to you some of the nice properties of publicly cryptography. It allows us to be really transparent with everybody in the way that we fundraise. That's the idea. The idea is that you can see all the money that we've had donated to us. And also, if you want to donate to us, it means that you know exactly who's in control of those funds. Now, there are some outlier cases, like, for example, we could have our keys stolen. Our computers could be hacked. We could have what's called the $5 wrench attack, where someone like beats the key out of us with a $5 wrench, and then we're forced to kind of surrender it. You wouldn't know in that instance, but then what we would have to do is we would have to tell everybody that that's what had happened, and then generate new keys and generate new addresses and go through this process again. You also notice that we're using HD wallets, which means that we can actually produce as many multi-sigs as we want. And so, you know, maybe for different projects, the things that are similarly linked to what we're working on here, we can, you know, generate new addresses for each one of those. Shinobi, any thoughts? Anything you want to tell everybody?
Insert Craig Wright key signing. But
Yeah.
it's just hopefully, you know, this can show everybody who's watching a little bit about, you know, how specific things are at the low level of the machine. You just something like a space that you see between characters on a screen can be a lot more complicated than that at the low level of the machine. And pretty much with everything that Chris has put up on this site, you should be able to go through and verify that all of the individual keys that sign this Merkle root add up to that multi-sig address. And then you should be able to take the master pub keys and essentially be able to audit receive to any address in that entire HD wallet. So any money that any of our viewers choose to give us, everything that we do with it, everywhere it goes, will be completely auditable, completely open. And if you see money move and you don't see an explanation from us, well, call us on it, because any money that we raise through this, we hope to actually reinvest into doing more content, actually providing more useful things for the users. So make sure you hold us to it.
Yeah, do that. I think Blake Anderson said that if we don't behave, he's going to demand all our private keys and he can become the government. Yeah, if this whole experiment in anarchy doesn't work out, guys, we're just going to evolve into government again because it just didn't work.
Well, all right, send us some funds already so we can bro down.
The bro down. Like, where's that bro down? I'm just in this for the money. I didn't even get into Bitcoin for any other reason. All right, nobody believes me whenever I say shit like that. But one day, it's just a really, really long con that I'm running here. I'll get you eventually.
I mean, isn't that what we're all doing? I thought this was.
I thought that's what we were all doing. Yeah, Bitcoin has a way of getting the dishonest people to kind of reveal themselves eventually, you know, with time. It just has that effect on people. Okay, anything else? We got it. We did it. We nailed it. And in the future, I do know how to fix this problem, by the way. I've already come up with a plan, but we didn't rehearse any of this, as you could probably tell. We checked on our own computers that the signatures work, but we just didn't check it like between us, like copying and pasting stuff. And once you start, you know, copying stuff out of a text box on a web page, which has got all kinds of formatting on it, you know, it ruins your signatures. So I do know, and I've already got a show in mind for how we can do what we tried to do before again.
Well, I mean, this was all like stuff we'd done before, you know, so we just freestyled it, and we thought we were going to get lucky, and it was just going to go perfectly. Oh, well.
Yeah. Cool, guys. Well, thanks very much for sharing your Saturday with us, or Sunday, or whatever day of the week you're watching it. And we'll see you next week, back for more shows. Bye-bye for now.